Hey guys, this is Mitch with FinePoint CGI, and today we're going to talk about how to build a 3D character controller in C# in Godot. So we're going to go through the process of building out our 3D character controller. We're going to talk about how to code the different interactions, so running, jumping, things like that. We're going to talk about how to handle our camera and make it so our camera can go up against walls and not get pushed through the wall. We're also going to talk about how to set up animations. It's a common thing that a lot of people don't cover is how animation trees work, how state machines work, and how the blend shape 2D actually operates. So once we're done with all this, hopefully you'll have yourself a pretty decent character controller. So with that being said, let's go ahead and get started. Okay, so the first thing that we're going to do is we're going to build out our character. Now, I already have a character built specifically for this tutorial, and if you guys want to know how I built that character, go ahead and take a look at my previously released tutorial where I talk about how to take a Mixamo character and basically compile all your animations and things like that and then put it out for Godot. Now, I do have a link to the starter scene, which is this guy here and this little character.glb. If I right click that guy and I make a new inherited scene, this is what you're going to see is a character object here. It's going to have some animations right here already created for it. So you can see my idle animation, my strafing animation, my walking animation, things like that. So make sure you guys download that starter scene. If you don't want to do that, that's totally fine, and you can actually follow this with just a capsule shape, or of course you guys can use your character if you have one. Now what I'm going to do is I'm going to right click my character here and I'm going to change its type, and we're going to make its type a character body 3D, and that's going to delink it from Blender. So if you have a .blend file or something like that, just keep in mind that you've now delinked from your inherited scene. So that's just something to keep in mind. Now, once we have that, we need to add some kind of collision to it. So we're going to right click our character, attach a child node, and we're going to add in a collision shape 3D. And then we're going to make our shape into a capsule shape. We're going to hit Control and we're going to drag this guy up 1 unit, and that's going to encapsulate our entire character. Now from here, we need to actually set a script for our character. So we're going to come into our character, we're going to right click it, attach a script, and we're just going to stick with character.cs, and we're going to use the character body basic movement template. And that's really nice because this template basically does a lot of that additional work for us. So if we click create, you'll see in a second Visual Studio is going to load, and I'll make it snap into the correct size for your guys' screen. And you can see here that it already did a bunch of the work for us. That's one of the really cool things about the template system is that it has a template already built for us. Now, if we go back to Godot, we hit Control S and we save this as player.tscn. We go back to our node 3D and we drag our player into our node 3D. You will see here is our player. Now, you can't use a character without having some kind of camera. So if we right click our character and we add a child node and we add in a camera 3D, we just drag him up like this and just kind of face it in the general direction of our player here. And we hit Control S and play. You will see, hopefully, if it all builds correctly, that we have a character here. If we hit left and right, you'll see we can move left and right, forward and backwards. We can move forward and backwards, and we can jump. So awesome. And if this is really all you need for your character controller, there you go. You have yourself a well-built little character controller. Now, in our case, I want to add in the ability to make it so that we can move our camera with our mouse. So if we close this, let's do some additional work here. So first things first, I'm going to decouple my camera from my character body. And the reason why I'm doing this is not because it's a better way of doing it, but it's because it's a different way of doing it. So when you decouple your camera, you're basically creating a node, putting your camera under that node, and having that node follow your character around. The nice thing about doing that is if you need to move your camera away from your character for some reason, you can. if you want to make some adjustments to your character without it affecting your camera, you can do that as well. So that's just something to keep in mind. Now I'm going to right click my node 3D. I'm going to add an child node and I'll add in a node 3D, and I'm going to drag my camera underneath my node 3D. So now when this moves, it's going to move my camera. And what I'm going to do is I'm going to rename this as camera controller, like that. And then I'm going to right click my camera controller. I'm going to attach a script, and I'm going to attach a camera controller.cs. We're going to go ahead and create that. And basically, to get it so that it follows our character, all we need to do is basically in our process, just get where our character's position is and then move it to that location. Now, you can do this in a lot of different ways, but the easiest way to do it is by going into your character, scene, and then coming over to node, groups, and then adding it to a group. And I'm going to add it to the player group. And that's basically going to allow us to get a universal reference to that player's location. So we can come over to our camera controller right here, and we can basically just say get node, get tree, dot, get nodes in group, player, and we need to cast it as some kind of object. So we'll cast it as a character because it's a character type. And then we'll pull back our first reference of that object. And you'll see that we have an underline here. So non-generic method, string name cannot be used with, I guess we can't use it with type arguments. We're going to have to do it like this. And then we'll need to say, if we come over here, character is equal to this. And we'll pull back our first element as a character. And that will basically cast it as a character object and dump it into our character value. Now from here, we can basically just say global position is equal to character.global position. And that'll basically handle that aspect. So now if we hit play and we allow ourselves to play, and you can see that it didn't work. Well, why didn't it work, right? It should have worked. I mean, if you look, we have camera controller. We have our script here, which has camera controller, and we have our stuff, and it should have worked. Well, here's the reason why it didn't work. If we look at our debugger and you look into errors, you can see cannot instantiate script because an associated class could not be found. Script res camera space controller.cs. So here's the thing. You cannot have a space in your file name of your script. And if you take a look at the actual script itself, you can see it's camera underscore controller. And Godot was nice enough to attempt to fix it for us by adding in an underscore. But the problem is that it didn't insert an underscore right here. So it's camera space controller. And so since there's a name mismatch there, it is a common problem that people run into where they add a space or something like that, and it completely bricks their entire C# project. That's just something to keep in mind. And you have to check for special characters as well. So if you're using a non-standard character set, then that can break your entire project as well. Same thing with using the sharp key or the @ key or the $ key. Any of those symbols can also break your project. So we're going to right click our character controller. We're going to rename it and just say camera controller with no space, and then we'll come in here and we will get rid of the space as well. And now if we refresh our screen here, and we're going to need to reassign it, so we'll just drag that up to our camera controller, and then hopefully if we've done everything correctly, if we hit play, it won't crash on us. It'll probably crash on us. And it definitely didn't work, so let's see what this is. So it says instantiated class could not be associated, camera controller CS. And let's take a look at the script, see if there's something wrong with the script. Probably. I thought I changed this, but apparently I didn't. So we'll do that, and then we'll refresh it, and hopefully it will work this time. There we go. And now we're basically back to where we were. Awesome. So now we got to get it so that our actual mouse can rotate our camera. And that is where capturing your mouse, and that is where the Godot event system comes in. So inside of Godot, we have this thing called the input event. And basically, it's a function that exists inside of the character controller that you can use to actually take your input events and then run code based off of it. So in our case, we're just going to come in here and say public override void input event. And what this is going to do is it's going to allow us to actually capture that event. And what this does is it captures every event that happens on your project. So you want to be really cautious with using these, okay? You should only use them when it's something that is not able to be done any other way. So for instance, every time you hit G or any key on your keyboard or anytime you move your mouse, this function is going to run. So you need to be super cautious about that. Now, in our case, we have to do this because we want to use our mouse motion to control our camera. But we need to know what our event is. So we can't just be like, hey, move our camera based off of our event when we don't know if it's actually a mouse click event or if it's a mouse motion event or if it is a keyboard press. We don't know. So we need to check for that. So we have to say if at event is input event dot mouse motion, like that. And if this is an event mouse motion, then we need to cast it as such, because unfortunately C# doesn't know that this event is a input event mouse motion. It just knows that it is an event. And to pull back the things that we require, we need to cast it. So we'll say input event mouse motion is equal to input event mouse motion add event. And then we can just take our motion and basically set our rotation. Now, inside of C#, it's a bit more finicky than doing it in other languages like GDScript. We actually have to set our rotation as one solid thing. We can't just say rotation.y is equal to this. We actually need to set up our stuff so that it is one giant equals, if that makes sense. We have to say rotation is equal to, and we'll have to say new vector 3, and we'll need to pass in some stuff. So what we'll do is we'll first pull out our X, and X rotation is actually important. If we take a look at our character controller here, and we look at our camera, and we look at these little lines here, okay? X rotation actually is up and down. So if we look and we do this, you'll see that it rotates the camera. You really can't see it because Godot likes to use pink, and pink is awful for this, and my compression's probably not helping. But if we rotate it on X, on the red axis, you can see that our camera goes up and down. If we rotate our camera on the Y axis, you'll see that our camera rotates around the character. And if we rotate on the Z axis, you'll see that our camera kind of cants to the side, if that makes sense. So we don't really want to rotate on the Z axis. We want to rotate on the Y and the X axis. And you'll notice that if we move our mouse side to side on the X axis, we'll want to move on the Y axis. And if we move up and down on the Y axis of our screen, then we need to do it on the X axis. So that's something to keep in mind. So if we head over here and we take a look at this, to do our X axis, so to go up and down, that means we have to pull our event relative Y. So we can say rotation dot X minus motion dot relative dot Y divided by 1000 multiplied by our sensitivity. Now you'll notice that this wasn't here before, and that's because I'm just realizing during the recording that this already existed, but basically I put a sensitivity value up here. Now the reason why I did that is because it's going to allow us to access this on the inside of the Godot editor. So make sure we add this guy up here and we'll be good to go. I forgot to delete that when I was doing my second pass at recording this part, so my apologies. And then we need to rotate on our Y-axis, and I'm going to hit enter so that way it just looks a little bit better. And when we do our rotation on our Y-axis, we need to do this our relative X. So we'll say rotation.y minus our motion.relative.y divided by 1000 multiplied by sensitivity and we should be good to go. And then we can just drop in a 0 right here on Z because we don't want to rotate our can't at all. Now, I know what you might be asking. Why are we using 1,000? Well, 1,000 is just a good value that translates from 2D to 3D space, if that makes sense. So technically speaking, it could be 100, it could be whatever you want. But I found that dividing it by 1,000 gives us a good 1-to-1 ratio in terms of movement. So if we hit Control S and we go back to our project here and we hit play, if we move our mouse, well, it kind of works, but not really. So what in the world's going on? Well, if we head back here and we take a look at it, you'll see that our rotation X minus our relative Y for our X value, that's correct. Our rotation Y minus our relative Y. We need to change that to relative X. And let's try that and see if that works. And there we go. Awesome. So now you'll see if we go up, you'll see we can get past our camera's rotation like that. And you'll also notice that we can go into the floor. And that's a pretty big problem. So we need to do something called clamping. And clamping allows us to clamp our camera in between two values. We only really want to clamp the top and the bottom of our camera, not the left and right. So let's do that real quick. So if we head back to our script here, and we'll want to clamp it on our X rotation, right? Because we have our X, Y, and Z. And since we're moving up and down, that is the X rotation. I know that's kind of confusing still, but that's just how it is. So we'll come in here and we'll say math dot clamp, and we'll clamp this value here on two values. So we'll just put in parentheses right here. We'll hit comma, and then we have two values that we want to clamp this guy by. And in our case, we're going to go -1, comma 0.25F. And those are just values that with my testing works. So I'm going to go with those. Of course, if you guys want to mess around with it, you're more than welcome to. So now I know I get a lot of questions about the difference between math and mathf. So what's the difference between math and mathf? So math is an integer math and mathf is float math. So if you're doing something that requires 1.25, you want to use mathf. If you want something that's going to go 1, 2, 3, 4, then you want math. So that's the difference between the two. Generally speaking, math is faster than mathf, but you lose the capability of using floats. So that's something to keep in mind. Now I'm going to hit Control S, and then we're going to go ahead and test this. So let's hit refresh, and you'll see if I go up, it now stops me from going any further. So if I go up, it stops. If I go down, it stops right about here. Now we could go a little bit lower than, I believe I did 0.25F. We could probably go a little bit lower than that if we want to, because looking at this, you can see that we get to about here-ish. So you could go a little bit lower if you wanted to give the character the ability to look up further, but that's up to you guys. You could set this to something like maybe 0.5F, and that would give you just a little bit more space. So if we hit play, we come down, you'll see that that gave us just a little bit more space. So that's up to you guys on what you guys want to do, but there you go. Now, something else that we got to check out is we can actually move our mouse outside of our screen. See that? And that's a really big problem because it basically makes it so that we can't control our character without coming over here and then kind of coming around our screen and then continuing around like that to do a full 360 on our character. So how do we fix that? Well, if we go back to our code here, we go up to our ready, which runs whenever our node enters our scene, we can basically update our mouse mode. And our mouse mode is like how our mouse presents itself within our game. We could just come in here and say input.mousemode is equal to input.mousemode_enum, and we can set that to captured. And that's going to capture our mouse. So if we come over to our project and we refresh, you'll see that now my mouse has been captured. So now no matter how many times I move it around or I rotate it around, it doesn't leave our screen. And we can hit Alt F4 to close our game. Now, something else I'm going to do real quick is I'm going to make it so that we can actually see what we're doing. So I'm going to click on these 3 dots up here. I'm going to add a sun and I'm going to add an environment, and that should allow us to actually see our scene. There we go. Now, once we have this, we're actually getting there, right? We can move our character around and we can actually use our character. But you'll notice that if we go up against this wall here and we rotate our camera, we go into the wall. Well, what if we actually want it so that our camera kind of zooms in to our character, right? If you've ever seen character controllers, a lot of times that's what they do, is they don't intersect into the wall. They kind of bounce forward into the character, if that makes sense. So how we do that is by using what's called a spring arm. It's an actual feature that the Godot developers have implemented that makes our life way easier. So if we right click our camera controller, we add in a child node and we add in a spring arm 3D, and we just put our camera onto our spring arm, that will basically take care of it for us. Now we're going to need to take our camera, we're going to need to zero it out. So let's 0, and then let's 0 our rotation out as well. And that way our spring arm is now actually taking control of our camera. So if we hit play, you'll see that we now are zoomed in on our character's feet. Now, obviously this is way too close for our comfort, right? We can't really use this like this, right? But what we can do is we can actually increase the distance that our spring is located. You can see we're about 1 meter away. We could change this to something like 5, and you'll notice that now we're about 5 meters away. And when we go up against the wall, it zooms in on our character, which is awesome. That's exactly what we want. But you'll notice that now we are not looking at our character. We're looking at our character's feet. We're actually zoomed in on our character's feet. And if you guys want that feature, that's great. But generally speaking, you want to look at your character's back, right? You want to look at where our character's head or our shoulders are located. So how can we do that? Well, we can set up what's called a look at and look at our character's shoulders. But to do that, we're going to need some kind of reference. So let's head over to our player and let's right click our character controller and add in a child node, and let's add in a node 3D like that. And then we'll take this node 3D and we'll just drag this guy up to the center of our character's neck, right about there. We'll rename this as look at, like so. And then all we have to do is tell our camera to actually look at that location. We can come into our camera controller right here, and we can go into our process node right here, and we need to get a reference to our camera. So we'll say get node camera 3D quote, and we got to get a node path. Now in our case, it's actually pretty simple. It's just spring arm camera 3D. So we'll type spring arm, I believe, spring arm 3D. We want to make sure we get that correct. Camera 3D like that. And then we can say dot look at, and we'll pass it something to look at. Now we don't want to look at obviously our global position. We want to look at our player's look at position. So we'll say get tree dot get nodes in group 0 as character. So we'll say character dot get node, and we're going to say node 3D as type quote look at, and then we'll just pass in our dot global position like that. And there we go. Simple enough. Now, something that we should do is we should pull this guy out, because having a get tree dot get nodes in group and pull back our first reference, doing that a lot is really slow. And a lot of times in code, you want to make sure you just pull a reference and hold on to it instead of pulling a reference every single frame. So let's grab this guy. Let's copy it. Let's put it up here like so. Let's get rid of character like that. And let's get rid of this guy like that. And then let's just come up here and say character like that. And that's going to basically allow us to keep that reference in memory. So we're not doing it every single frame. We only have to do it once, and then we're good to go. Now we can just hit Control S, hit refresh, and hopefully it will work for us. And there you go. Now we are focused on our character and our character's shoulders. Now you'll see that if I come down like this, we actually are going through the floor once again. So we'll probably need to come in here and make a quick adjustment to our clamp here. So we'll just put it at 0.25 and see if that works, because it's probably my fault why it's doing that. And Godot just crashed again. So something that I've noticed is this is the third or fourth time Godot has crashed randomly within the C# version of it. I'm not sure if this is a bug inside of Godot, but it definitely makes things difficult when you're trying to do stuff. And unfortunately, I don't get any error messages or anything. It's just a pop-up that's blank. So I will be right back. All right, so now that Godot's back up and running, let's take a look at our stuff here. So basically, we have it so that our character can actually go forward, backward, side to side, and you can move the camera around. So you can see forward, backward, side to side, which actually we should probably rotate our character 90 degrees so that it, matches with what we have. But you'll notice that if we move our camera, our controls still are rotated incorrectly. Our controls are not actually moving with the camera location. So how do we solve that? Well, to do that, we need to come into our character and make it so that our character can actually face the direction our camera is facing. So the easiest way to do that is actually to do a look at. And you could do some fancy math and things like that to make it so that your camera, basically when it's out here, you could say, okay, do the opposite of that. So somewhere over here, and then get like the negative values. But that's a lot of work. And it's a lot easier to just right click on your camera controller, add in a child node and add in a node 3D. And then just add a look at, much like we did for our camera. So if we just place this out in space like this and name this look at like that, then we can actually use that to fetch our look at location. Now, the way we're going to do that is we're going to come into our camera controller, we're going to go into our node, and we're going to grab our group, much like we did with our character here. We need to have some kind of universal method to fetch that camera location. So we'll come in here and we'll just type camera controller like that. And I'm going to copy that so that way I have it. And then we can come into our character here and we can basically just look at where our camera is facing. So if we come in here, we can just type look at get tree dot get nodes in group, paste that camera controller, fetch back that first element dot. And you'll see when we do a dot, it doesn't actually come up with anything, right? Now, we could do this one of two ways. We could get a reference to the object like so and just say camera controller and make that equal to get tree that as a camera controller. And then we could come in here and just say look at camera controller dot get node like this, node 3D, and fetch our look at like that dot global position like that. And we could do it this way, or we could just wrap this guy in parentheses and then just basically say camera controller, and then we could go from there and pull back our node. It's up to you guys on which one you guys want to do. But right now I will use this. So we hit Control S, we come back here and we refresh. You'll see that our character is now facing our camera. Now that's just because we need to flip our character. But if we hit W, you'll see we're going forward. A, we're going left and right. And we can actually walk around as if our camera is dictating where our character goes. So that's awesome, right? So kind of, what if we want it so that we are able to pivot around our character? And what if we want it so that we can't look up and down and have our character actually look up and down? Because we don't want our character to actually look up and down when we're moving our camera, because that's going to cause some issues, right? Especially if we do something like jumping or something like that, it could cause problems. So how do we fix that? Well, if we head back to our character here, when we're fetching our look at, we're just grabbing our global position here. And what we should do is we should just do the X and Z values, because we don't need to do the Y values. I don't care which direction the character looks up and down. I only care where the character looks left and right, if that makes sense. So we can come in here and just say vector3 look at is equal to, and we can just grab this bit of code here, copy it, paste, semicolon, and then we can just come in here and say new vector3 pass in look at .x comma global position .y comma look at .z, and that'll basically allow us to control our characters look at, so they don't look up and down, they only look left and right, and that's it. Now, the reason why we want to use our global position is because our global position is always going to be the correct position, if that makes sense, to where our look at would be. So that's just something to keep in mind. Now, if we hit Control S and we test this real quick, you'll see when we look up and down, our character no longer looks up and down. They just look straight ahead, which is perfect. Now, let's solve the issue where our character's not looking in the correct direction, and let's solve the issue where, what if I'm not moving and I don't want my character to rotate with me? What if I want to look around my scene and not have my character follow my exact movements? Well, to get our character to rotate correctly, if we go into our character scene, we can grab our armature and just flip it 90 degrees like so, and we're good to go. We'll hit Control S. And for our character to do kind of that nice rotation thing where it's only when we're moving, if we grab this guy here, we hit Control X, we come down here and we say, if direction does not equal 0, then look at this location. And there we go. But what this is going to do is it's going to make it so that our character snaps into position, and we don't want that necessarily. What if we want our position to be kind of like a lazy rotation? Kind of like if I told you to look in a direction, you're not just going to quickly snap into position. You will slowly turn your head and look at that position. So the best way to do that is with what's called lerping. And lerping allows you to lerp between two values. Now, the easiest way to do that is to get your character's last look at position, then lerp between the last look at position and the direction we want to go, and then set our last look at direction equal to our lerp direction. So that's pretty simple to say, but how do we actually do that? Well, if we come up here and we set up a vector3, and we'll call it last look at direction, and we'll make that equal to a new vector3 like so. And then if we come down here, we can just say vector3 lerp direction is equal to, we could type lerp, but you'll see that nothing happens. It doesn't actually exist. We could go Godot.lerp, but that also doesn't exist. So where do we find lerp from? Well, we find it with mathf.lerp, just like that. Mathf.lerp is where we would fetch that. Instead of fetching it just from the Godot code base, we can actually just pull it from our mathf libraries. And now we have a from, a to, and a wait. So our from is our last look at direction. Our to is our look at direction, which would be this new vector3 right here. So we'll copy that guy. And then our wait is how much we want to do it by. So that's going to be 0.0f, like that. And you'll notice, well, hold on a minute, that didn't work. Cannot convert Godot vector3 to a float. And that's where C# and Godot separate quite heavily. C# expects for you to have that knowledge that you're going to need to break apart your vector math into 3 separate maths and then return that value, whereas Godot will just do that for you. So for us to do this, and for us to do this efficiently, we're going to create a helper function that will do it for us. So we'll come down here and we will add in a function. So we'll say private vector3 lerp vector3, and we'll pass in a vector3 value to lerp. like that. And then I'm going to do what's called a shorthanded function. So I'm going to hit equals pointer new vector 3 like this. And then we're going to lerp those values. So we'll say right here, we'll say mathf.lerp, and we'll take our from, which will be our value to lerp, .x, and then we need to give it some kind of value to lerp too. So we should have another one, vector 3, value to lerp 2, and we'll pass that in here. So value to lerp 2 .x or comma, and then we need a weight. So we should probably pass that in as well, like that. And we'll pass in our weight, just like that. And then we'll do a comma, and then we need to do the exact same thing again. So we can grab this guy, pass it in, and then do one more. Comma, pass this guy in. We'll say Z, Z, Y, and Y, just like that. And now we can just come up here and say mathf.lerp. And instead of doing that, we can just say lerp vector 3, pass in our 2, which would be our last look at direction, comma, our look at, comma, and then our weight, which in our case is going to be something like 0.05f. Now, something that I made a mistake on is our last look at direction is up here, and it actually should be all the way up at the top. We don't want it inside of this function. So we'll just go ahead and grab this guy, Control X. We'll come up here and paste it in like that. And that should allow us to use it. So once we have our lerp direction here, we can basically say, okay, we're good. We can look at our lerp direction like that. And then we can set our last look at direction is equal to our lerp direction. And hopefully that should do it for us. So now, if we've done everything correctly, we can come back here, we can refresh, and let's see what it does. Well, it failed to build, so that's never a good sign. So let's see. We need a semicolon. So I forgot to do a semicolon right here, so we'll do that. And hopefully, if we hit play, it will build. There we go. And we have a failure because I need to be on my node 3D. So we'll hit play. And you can see our character is not rotated to our camera. And then when we hit forward, now our character rotates to our location. But you'll notice that for some reason, our character rotates to kind of follow our mouse location. And I thought we fixed that, right? Well, here's the reason why. So if we take a look at our values here, we are lerping our Y value from a value to another value. And if we take a look at what we're passing in our last look at direction, which should be a vector 3, 0, which is generally fine, but it's probably not. And if we look at our look at, we're passing in our global position. So this isn't going to work because we're just passing in our actual global position, where we're going to. And since we need to set our global position.y equal to our player position so we can fix that rotation issue, we have to do that somewhere. So we'll do that right here. So we'll say look at is equal to look at new vector 3 look at .x, comma, global position.y, comma, look at .z. And there we go. And hopefully that will work for us. So let's come back here. Let's refresh. And you'll see that that fixes our problem. And you'll also notice that our character doesn't just snap into where our camera is located. They kind of gradually slide into that location. And that's basically how we'll solve that. Now, something you may have noticed is your character is rotating quite a bit when you turn left to right. And the reason why that is because your look at position is probably too close. So if we pull this really far out, that'll help mitigate that issue. You can see here. Now the character doesn't rotate very much at all, and it basically solves our problem. Now, if we wanted to, we could make it so that, we want our character to only rotate, for instance, when we click another button. All you really have to do is just basically pull this look at section here and basically just put that underneath wherever you want your character to actually, when you want your character to actually look at a specific position. So that's something that you could do. At this point, we basically have everything we need. We have the ability to move our character, jump, and move our camera. So if this is basically what you were looking for, congratulations, we're basically done at this point. But how would you add movement? Well, basically, to add animations, we have to go into our player controller here. And we can come down here and take a look at our animations. Now you can see we have a bunch of really cool animations right here, right? Now we could call them out inside of our code, but that can get really difficult. And that is where the animation tree comes in. It simplifies calling all of your animations to a singular area, and you could use parameters to basically determine which animation you want to be in. So how do we use an animation tree? Well, if we come up to our character, we right click, add in a child node, and we add in a animation tree node like this. You'll see if we go to our inspector, we have what's called a tree root right here. If we click on that, we have a bunch of options here. Now, I'm not going to go in depth on each option, but I will go through two of them. The two that we'll be going through is the blend space 2D and the node state machine. Now, I'm going to click on the node state machine because that's the one we're going to use first. And then we'll use the blend tree in one moment. Once we have selected our node state machine, we need to select an animation player, right? You can see it says animation tree is inactive, activate, enable playback, and check node for warnings. And you'll see if you see a warning here, it says path to animation tree node containing animations is not set. And the reason why that has to exist is because we need to play our animations through some kind of animation player. Animation tree just basically tells animation player what to play and when, not exactly how to play animations. So to hook up our animation tree, we can come over to anim player and click assign. Then we can assign our animation player and we'll hit OK. Now, once we have that, we're ready to go. We can actually start using our actual animation tree. So the easiest way to use your animation tree, in my opinion, is the actual animation state machine here. Now, the easiest way to do a lot of things is using the state machine. If we right click add animation, you can see we have a bunch of animations right here. Now, I'm not going to go into super detail about how to do everything inside of here, because there's so much in here, it's kind of crazy. So what we'll do is we'll just drop in idle. And then if you click up here on the connect nodes button and you drag this guy to here and you let go, and then if you click on this guy here, you should see your player start to play the animation. Now, if it doesn't, then you have to click on your animation tree and turn it to active. And you'll see that your player is now playing that animation. Now, if you want your character to play, for instance, a walk animation, you can do a transition into that walk animation. You can click and drag and then let go, add animation, walk, and then click, and you'll see that the character is now playing the walk animation. Now, you'll notice that the character stopped playing the walk animation once it completed. Now, why is that? And the reason why is because if we go to our animation player, and we go to our walk animation, you'll see over here on the right, there is a animation looping button. You click that, now your character will loop that animation forever. Now, that means we should also do that for something like falling idle. We should turn that on. We should do the same thing for strafe left and strafe right. And we should probably do that for idle as well. So we'll turn that one on for that. And then we'll go back to our animation tree, and you'll see that we can go from idle to walk, but we can't go from walk to idle because there's no link back to walk. So if we click and drag this guy down and let go, you'll see our character is now freaking out. So what happened? Well, our transition is happening instantly. If we click on this thing right here, this little transition, you can see we have this thing called switch. We can change our switch mode. So you can see if we change this to end, you'll see we'll do our idle animation. And then when it finishes, it's going to go into our walk animation. And if we change this transition as well to end, it's going to do the same thing. Now, in our case, we don't really care about this, right? So you'll see once this finishes, it's going to do the walk animation and it'll switch back immediately. Now, that's great and all, but that's not really what we want. We want it to switch immediately, right? We want for our player to be able to stop idling and walk immediately. So what can we do to make it so that it doesn't go crazy like that? Because if we switch it back to immediately, like so, and we switch it back to immediately, you'll see that they freak out. Well, that is where advanced comes in. So you can see that there's advanced. And you have this thing called a condition. And if you type in this condition, moving, you'll see that now we are not going into our walk cycle. And if we click on this transition and we change it to idle, like that, you will see that if we go into our walk cycle, so if we click on this little button here and we do a transition, you'll see that we're not going into our idle cycle. However, if we click on our animation tree and we go over to parameters, conditions, you'll see we have idle and moving. So if we click the checkbox right here, now we are in our idle. If we click on our moving checkbox, now we are moving. Easy enough. And you'll see if we uncheck moving, we're still moving. And that's something to keep in mind. So this is cool, but how do we hook this guy up? Well, this is actually pretty simple. If we go into our code here and we come up to the top and we add in a reference to our animation tree. So we'll say animation tree like that. And then we'll come in here and say public override void underscore ready. And then we'll say tree is equal to get node, and we'll pass animation tree, and we're going to get back our animation tree. So it should just be as easy as grabbing this, pasting it, and then there we go. And now once we're in here, we'll come down to the bottom here, which is where I usually like to do my animation switching logic. And we'll say animation tree dot set. And we'll need to set a name of a property and the variant. And this is where things are going to get difficult. So if we hit quote, we don't have any IntelliSense. So we're going to need to know exactly what we're doing. So if we come over here and we click on our animation tree, we hover over idle, you'll see it's parameters / conditions / idle. So what are our conditions for idle? Well, if a character's idling, they're usually on the ground and they're usually not moving, right? That's an easy way to determine if you are in idle state. So we'll come over here, we'll put a parentheses like so. We'll say is on floor, comma, and if you look up here, we have a section here where we're getting our input direction. If we have an input direction, we know that we're moving, right? We cannot move without an input direction. So we'll say and input dir is equal to vector2 dot 0. And there we go. So how do we know if we're moving? Well, it's the exact same thing, right? We are on floor and our input direction does not equal 0, right? Because we know if our input direction does not equal 0, we must be moving somewhere. And then we can just come in here and update this to say, I believe our parameter is moving. So we'll say moving like that. We'll hit Control S and then we'll hit play. And now if we hit W, our character walks. If we let go, our character stops walking. There we go. Easy enough. So now what if we want to handle jumping? So you can see when we jump, our character doesn't actually do a jump animation. Well, that's pretty easy. If we head back to our animation tree here and we draw out a line from our idle and we let go, we can add in an animation called falling idle. And that's basically our character falling, right? And when your character falls, they need to be able to land. So we're going to drag this down, add in animation, fall land. And then when they land, they can go back to their idle state. Now you're going to see they're going to freak out again. So let's come in here, add in a condition, call it falling. And then since we don't want to transition immediately from fall idle, let's come in here and just say landed like that. Now something to keep in mind, and I'll show you guys this. If we come in here and we scroll down and we duplicate these parameters and we have one for falling like so, and we have one for landed, I believe is what we called it. Let me check real quick. Falling and landed. So if it's falling, we know that if we're following, it's not on floor. So we know that that's true right there. If we are landed, that means that we are in fact on the floor. Now, something to keep in mind about state machines is it doesn't matter if landed is true if we're in our idle state or if we're walking, right? Because if we do this, there are no transitions from idle to fall land. So falling or so landed can be true, and it's not going to cause any issues. So that's something to keep in mind. So once we have this, if we hit Control S and we refresh, you'll see once we jump, our character does our animation. But you'll notice that they immediately basically like pop almost into their land. But we don't want that, right? We want our character, when they fall and land, we want them to actually land and play that land animation, right? So how can we do that? Well, if we go into our animation tree, we can come into this transition, go to advanced and change, go into switch and change it to at end. And then we can hit refresh and you'll see our character lands. And there you go. Now there's a little pop there. I don't know if you've seen it. When you jump and you land, there's kind of like a little secondary pop there. And that's because of the animation choice I chose. So don't worry, if you choose a different animation, it will be better. Or if you just want to get rid of that fall land animation, that will also solve your guys' issue. But in my case, it's fine for the tutorial, but that's just something to keep in mind. Now, something else that you'll notice is if we walk and we jump, you'll see that our character does not go to idle state or does not go to jump state. You'll see that? Now, why is that? That's because walk does not link to fall idle at all. So it's not going to work. So we can just kind of drag this guy here like so, and then we can click on this guy and say falling. And when we're landing, we also can go from idle to walk, or we can also go from fall land to walk, right? So we can just drag this guy like that. And there we go. We could just say if we are moving, like so. So now we can jump and do fall idle, and we can land, and we can walk, and we can idle, and we can fall idle. Easy enough, right? So if we refresh this guy, we come in here, and we're moving around and we jump. You can see now we can do our jump. If we land and we're idle, our character does their land animation. When they jump and they land, they don't do a land animation because we don't want it to do that full land animation. Now, something you'll notice is if we're moving around, you can see that our character kind of snaps into position. And if we jump and we're moving, you can see how it's even worse, right? It just kind of does this big snap here. And that's where transitions come in. So if we come into our animation tree right here, we select our fall land, let's say, and we come over here and we select our transition and we come over here, we look at our what's called XFade time. XFade time will actually fade animations together. So if we set it to something like 0.2, which is kind of like my go-to for animations, if you set it to 0.2, that'll give you a good solid transition, if that makes sense. So now basically what I'm going to do is I'm going to run through all of these guys and I'm going to transition them to 0.2. And now I'm going to hit refresh and you'll see if I move, my character doesn't quite snap into the walk animation. He kind of smoothly guides into the animation. If I hit space, you'll see that when I go into my walk, my character kind of, instead of straight up snapping into the position, the character kind of glides into that position. It makes it a little bit smoother, a little bit easier to work with, if that makes sense. And at this point, basically, you have the basic understanding of how to set up your animations. So now that we kind of grasp the basics of a state machine, let's talk about how we can do something a little bit more advanced. let's talk about how we can do a blend space 2D. So if we head back here, when you're doing something that requires multiple transitions or that have things that kind of transition almost like a coordinate based transition, that's when you want to use a blend space transition system. So if we come up here and we right click and we add in a blend space 2D, and we grab this guy and we transition to it, and we add in an advanced transition and we say moving, and then we transition back down to this guy whenever it's idle, and then we'll transition to this guy when he's falling. We'll come in here, falling, and we'll grab these guys and set them to 0.2, much like we were doing with our walk, and then we just delete our walk like that. Let's head into this and take a look at some of the options here. So if we click on this little pencil, that will let us go into it. But before we do that, let me give you guys a quick, basically brief on how cool this is. So something that's really cool is how you can actually do sub animation trees in here. So you could do a sub blend tree or a blend space or a state machine. You can actually have state machines inside of state machines that are controlled by other animations that basically control blend spaces. So you can get really in depth and you can get as far down in this root path as you want, and you can actually build really complex animations with this system. And I'm just kind of scratching the surface with how all of this works. So there's going to have to be a whole dedicated tutorial series or just tutorial on this. Something I've been investigating is how I could use this to execute code. I think it would be cool to make some finite state machines with this, but that's something for me to kind of research and pay attention to. But to get into a sub node basically is by clicking on this little pencil here. So if we click on it, you'll see that we are now in a blend space 2D. So the way a blend space 2D works is by basically taking this guy and moving it around, and based off of wherever it's located, it will blend between your animations. So what does that mean for you? Well, if you come over here to the pencil and you click right here and you add in an animation and you add in the strafe left animation, and you come over here, you click add animation, strafe right, and then you come up here and you click and you add animation, walk, you'll see suddenly you have a triangle. And then if you click down here, add animation, walk, like that, you will have a full triangle. Well, it's more of like a trapezoid, I think. And if you click and you drag this guy over to the right, well, if we're in the correct state, so let's go into our root, let's click on our blend shape. There we go. So now it's going to play that animation. You click on the pencil and we move this guy to the front. You'll see that now we're walking forward, moving this guy to the left. Now we're walking left, and move this guy down, and we're once again walking forward. Now, obviously, we don't want to walk forward for this one. So what if we click on this guy, we come over here and we change it to play mode backwards. Now our character's doing a backwards walk. Now we can walk forwards and backwards, left and right. Easy enough. Now, something to keep in mind about this is since it goes off of coordinates, you're going to have to be cautious with how we do our movement. Inside of the code, since this works off of values, we're going to need to lerp our values to get a nice smooth transition. So I'll show you guys how to do that. But first, let's make this part work. So if we come in here and we come down here and we actually go into our animation tree, you'll see that if we hover over this, you'll see we have properties, parameters, and you can't quite see it on your guys' end, but it's blend space 2D blend underscore position. So if we come in here, we can basically duplicate this guy, and we could say conditions. I believe it's under blend space 2D. So /conditions/ blend underscore position, like that. And then we can just set it as our input direction, like so. And that should hopefully just work for us. So basically what it's going to do is if we go into idle, it will jump out of this blend space 2D. If we go into moving, it will go into this blend space 2D. And if we're falling, it'll automatically drop out of this blend space. So in theory, if we hit play, this should work. So you'll see if I hit W, the character walks forward. If I hit A, well, not much happens. Our character's not doing what I expected, which is about par for the course for this. So let's take a look at what's going on. So if we look at our code, we are putting in our input direction. Oh, I think I know what's going on. So when we did our parameters blend space 2D, if we hover over this, and I'm not sure if you guys can see it, but it says properties parameters blend space 2D blend position. And we have conditions blend position. So if we get rid of that and we hit Control S and then we refresh, let's take a look at it. We hit W or front arrow, back arrow, left or right, left like that. And there we go. Cool. I think that'll work. Though I do think I'm getting some kind of backwards motion. I think I have my forward and backward reverse. I think input dir might be putting ourselves in a backward and forward reverse here for some reason. So we might need to just grab our direction instead. So let's try direction. So we'll do this. We'll say new vector 2. This. We'll say direction.x, comma, direction.z. Because we don't want to pull our direction.y, because if we pull direction.y, that's our up and down value, not our front to back. So we want x and z. And then if we refresh this, let's see if that fixes our problem. And if not, we'll have to do some inverting stuff. No, I think it's still backwards. But let's see what's going on here. So we go to our animation tree. And let's grab this guy. Let's select this point. And let's drag this guy down. Let's select this point, drag this guy up. And that'll basically flip our positions. And if you want, you can always just kind of drag these guys like so. If it goes outside of the bounds, what'll happen is that if we put this at 1, you'll see it still does the proper animation. So that's just something to keep in mind. So now if we refresh this, since we flip these, that should solve our problem. So if we hit W, no, it's still, now everything's backwards. That's interesting. So that's not ideal. I'm curious what's going on here. There we go. That's better. I just had to go back to input direction and that solved my problem. So there you go. So now your character is doing proper animations like you would expect if they were walking like that. Awesome. Cool. All right. So now, what if we wanted to lerp between these values? Well, basically, we can do the same thing that we did down here with a lerp vector 3, but instead we could do a lerp vector 2, right? Or we can basically just kind of cheat it a little bit and basically just do a math f lerp our input direction. So what we'll do is we'll come down here and we'll say last input direction is equal to input dir, and then we'll just copy this guy. We'll come up here and we'll say vector 2 last input dir, and we'll make this equal to a new vector 2. So we'll just do new. We'll scroll down here. We'll just say new vector 2 math f dot lerp, and then we'll take our from, which will be our last input direction, comma 2, and we'll pass in our input direction, and we'll need to pass in a weight. So we'll do something like a, let me see, what did we do earlier? 0.05. So let's do a 0.05 f, and then basically let's do the same thing for our other vector. Now we're going to need to pass in a x and y value, so we'll just say dot x like that, and we'll also do that here. So dot x. And then we will grab this guy, copy it, comma, paste, close that parenthesis off, do dot y and dot y. And hopefully that will work for us. So if we hit Control S, we hit play. We have a failure. So it says that we are missing a parentheses here. It says parentheses expected. So we'll add an additional one real quick. And then we will hit play and let's see what happens. So left, up, and you'll see that it's a lot more smooth. It's not super smooth. So if we set this to something like maybe 0.15, perhaps, if that'll give us a better value here. Let's see if that'll give us a better, more reasonable value. There we go. And that'll smooth out our movement just a tiny bit. Awesome. And that's basically how you can build a 3D character controller with animations using a state machine and a blend space 2D. And something I just noticed is that we're going to need to drag this guy up here and add in the advanced moving. There we go. And that'll solve that problem. But if you like this video, go ahead and hit that like button. Hey, you know, if you dislike that video, go ahead and hit that dislike button because I'm here to make content for you guys. This video was a viewer suggested video. So, hey, you know, if you have any suggestions, throw them in the comments below because that's pretty much how I do all of my content. And what's next on my list is I'm going to be recording my item investigation system for my horror game. So look forward to that. And hopefully we'll get this horror game moving a bit quicker with some level design stuff and maybe some sound asset creation as well. So look forward to that. And hey, if you have any questions or comments, please leave them in the comments below or hit me up on Discord. Link is in the description and I'll be more than happy to help you out with any issues you might have. But that is all I have for you guys today. So thank you so much again for watching and I will see you all next time. Thanks.